Okay. See if that goes back in here. All right, got that. Now let me get Elmo trying to work. ImageMate. All right, now ImageMate's up. Yeah, exactly. Finally, it works. Okay, share screen again. I wonder why it does that every time that I share screen twice. Just a quirk of my system, I'm sure. Okay. So do you remember on the video when I said generators can be all different sizes? Look how big those generators are. They're huge, right? That is at the Hoover Dam. That's a room full of generators. Each one of those is a generator. What is the Hoover Dam again? So it's converting what into what? Or transforming what
Water into energy.
So water would be motion energy, right? Because they're capturing it moving, right? Motion energy into what kind of energy? Something more specific than something. What are those generators converting it into?
Electrical energy.
Electrical energy. Thank you, Sky Unit.
Yeah, that's
Please don't tell me. Oh, there they are. All right. Can someone turn off the lights over there? The bottom one? That is both. All right. So I brought my generators from home since they're, school supplies and all. Okay. So there's the light bulb. I know you can't see any of it right now, but I'm going to turn this as fast as I can. Watch for a little spark of light. It takes a lot to make this thing light up, just the least bit. See it?
No. I think that's all. You see a black screen? Yeah.
Mostly black screen, yes.
But I think I just saw something. Yeah, that's there it is. It's moving.
Whew. You guys saw me teasing my son trying to do this because it takes a lot of energy. It takes a lot of chemical energy in your muscles to make this work. That's why I was taking turns with different people doing this. Yes, my wrist. This bracelet. Makes my fingers go numb. Oh, it lit up just then. Let's see if I can make the other one work better. We've got two of them that work now. The light bulbs they give us, of course, don't work very well. It took attaching 4 different light bulbs to this one to get one to work. Isn't that great?
Yeah.
Okay, so here's the second generator.
That will work better?
Yep, did you see it right off the bat?
No. I see something. I see something.
That's not it lighting up. Okay, turn on one of the lights. Okay, that's closest to it. Okay, so yeah. There you go, perfect. Okay, now watch for the light bulb light up.
Oh.
You see it?
Yes. No. I did.
It's not yellow, it's going to be almost blue when it lights. I am. Okay, anyway, it takes a lot of turning it very rapidly. I don't know if you can tell, my hands are very red. I'm turning a little nail. So can you see the advantage of these that are on motors?
That would be way easier.
Far easier. And then this one, which I wish they'd given us teachers, it has little knobs that turn. That would be a dream as opposed to a nail that you rapidly jerk back and forth. That you try not to knock all these magnets and little hex nuts out of configuration.
Yeah, I will be way easier with that.
That's about as janky as possible. And then what they want us to do for 10 labs afterwards is beyond ridiculous. That's why I cut off the last 10 labs. Okay, so this is a room full of generators. What do you notice on the side?
There's rail. It's red.
It's red, just like this, right?
It looks like a drone.
And what did I tell you in the video that red is? What? What kind of wire? Copper. Okay. That red is an enamel coating to keep people from getting shocked, so you don't have electricity sparking out. You wouldn't want.
Wire.
That's all wire.
Oh,
That's a lot of wire, isn't it?
it's all the wire from the world.
No, but that is a lot of wire.
Mhm.
How do you think those generators, that room full of generators, compares to that little janky generator that my husband, my son, and I built?
Way better.
Way better. What do you mean?
Yeah, you don't have to hand crank it.
Yes, you don't have to hand crank it. What else?
They're way bigger.
They're far bigger. So do you think they make a lot, or
A lot of.
they transform a lot more energy?
Yeah.
And the fact that water is flowing through them, the water is constant motion rather than someone using their hand to flip a nail back and forth rapidly, right? And magnets, because my hands will be having issues with feeling for the next few hours. Okay, so do you think there's a lot more parts involved in that? Do you think they cost a lot more? Each of those spools of wire, when I priced them on Amazon, they were $30 to $50, depending on which person I went with in China. Michaela, paying attention to the topic, okay? $30 to $50 a spool. And when I say a spool, this is a 100-foot spool of wire. Through the school's vendor, which is way overpriced, just like the vendor they use for all these technology pieces. They're way overpriced. Through the school's vendors, $300. Okay. When I was spooling one of these on, my husband was trying to take out the kinks. In doing so, using the pliers, two sets of pliers, he broke one. And I was like, ugh. And my husband's like, just breathe, it's broken, it's done now. What do you do with it? Are you supposed to turn it into school or what? Because that was $300 loss for the school. And I said, no, because I mean, technically the students were supposed to be building this, but Mr. Williams and I both agreed that would be like a phenomenal waste of money after talking with the other teachers around the district. So it's going to be something that I built with somebody who's good at science help, which is Colby, because Colby's really good at engineering. So I can do whatever I want to with the wire. So my son's taking the wire and reselling it because it has a little value. Copper as wire. Anybody ever heard of people breaking into AC units? Anybody ever heard that? Nobody?
Yeah.
So my husband owns some rent houses and partially owns some other rent houses, like 50 rent houses in total. People routinely steal those outside central air units because they have copper wire in them. Copper has a high value. So that would be worth a lot, wouldn't it? Copper. So like I said, this little bit from Caddo Vendors worth $300. Okay. Let's see. It doesn't even really weigh that much.
For $50.
And my husband had said, when I told him what I was having to get, the spools of wire, he was like, oh, Heather, that's going to cost a lot. And I told Mr. Williams, surely you don't have to use the Caddo vendor. Pass that around. You know how light that is. That's a Caddo vendor spool. That's $300. A spool. And I was supposed to get a spool for every 5 people, every 5 students, every year. And I was like, Nah.
$300.
Yeah. Because that's to the Caddo vendor. I'm like, y'all silly for buying it at the full price. If you can go straight from China, get it from Amazon, and get it for $30 to $50 a spool. That's a sixth of the price.
Mm-hmm.
So that's what I did. I asked Mr. Williams, can I use the 4th grade budget last year and get it through Amazon? Now, it took like 6 weeks to get it in, but I was willing to wait.
But who cares?
Who cared? It cost so much less, like a reasonable price,
It's probably expensive.
It's crazy expensive, but it's less than gold. Gold does a better job of conducting electricity than copper does. Silver does an okay job of conducting electricity. But obviously, if the metal costs that much, it must do a pretty good job of conducting electricity, right? That's not even pure copper. That's mixed with other things because copper itself would probably be too soft. It's not that heavy, is it?
Yeah.
And it's really thin wire because that's going to be the one that's used well for making an electromagnet.
Well, I think it's because these
And it totally will cut your finger when you're making these things. So I was cutting in my fingers doing it. Okay. So how is this similar to what my son and I built? How are those big generators similar?
They both have wire wrapped around
They both have wire wrapped around them. Yes. How else?
them.
Well, that one's humongous. Mine is around a toilet paper tube. But how else are they similar though?
They both give energy.
They both give electrical energy. How else are they similar? How else are they similar, guys? Look at them. Sky, you know.
They both transform motion energy into electrical.
They both transform motion energy into electrical energy. How else are they similar?
They're both light. No.
I bet that's not light. Mine's light, but I bet that's not light.
That's like 10 million pounds.
Yeah, that's probably, I don't know, 10 or 12 of them right there in that one row. What is it, Michaela?
They do both have wires.
They have what?
Wires.
Wires. They both have wires. Yes. That's got a lot of wire. Hunter, she's trying to hand it to you, baby.
Oh, no, this. They both cost a lot.
Yes, they both cost a lot. Yes.
Even though that's like cheap. But
The wire costs a lot, but the rest of that is totally cheap materials. That's where it's funny. They give me really cheap LED lights that keep blowing out really fast. That's what happened with the first one, why it didn't light up on the video, because the LED light blew out that fast. They're not even as good as Christmas lights.
No wonder.
And I'm like, why are you going to give me a $300 spool of wire and 1 cent LED lights? You make no sense. And then you're going to put it on a toilet paper tube. Thanks for that. Really classy. Keeping it classy, y'all. Okay. See, that doesn't weigh very much to cost $300, does it? It's amazing what metals cost, right? And gold is very useful for a lot of things. And gold is the best conductor of electricity. Why wouldn't places use gold?
Because it's the millet.
Figure it out.
It's expensive.
Yes, that's exactly it. It costs so much. Yes. Just like diamonds are very good at cutting things.
I've never seen a
And-
diamond.
Well, actually, they use diamond bits in medical uses, medical purposes. Yes, ma'am.
My big brother, James, he hates it when Aiden uses expensive blocks in Minecraft. Because then it'll be hard for him to get more once we switch to survival mode, once he's ready, which will be like a couple years.
They actually use diamond bits in vision when they're like, when Colby was 2 or 3, he scratched my eye through several layers. And that can erode and cause ulcers in the eye, and mine did. And it causes vision loss, vision problems for several years. And in order to prevent infections, they have to scrape away that part of the eye so that it will heal again. Well, they have to use something similar to a drill bit, but it's made for vision. So they have to be a lot more careful with it, right? And you have to go to specialists for it. It's not like you go to Walmart and go to an optician or whatever. So the doctor did that several different times to fix it. And he said the last time, because I kept having to come back in, he said, well, next time we'll use a diamond drill bit. And I'm looking at him going, what? Huh? Because they use numbing drops and you don't feel any of it. It doesn't hurt or anything, which is good. Well, then in dentistry, they also use diamond bits because they're the hardest, the sharpest, and the most precise. Pretty cool, right? You don't feel it. They numb you. You don't feel any of it. Okay. So what's similar you guys missed? It's round. Just like a wheel, it turns. It's round, right?
It sort of looks like yours, but it's bigger on the top. But the point both have wire.
They both have wire. They both convert motion energy. This one from water, that one from my hand, into electrical energy. Both cost a lot. Mine just because of wire. Okay. our generators are tiny. That one's huge. How is our generator that we made like the windmill? Michaela, you gonna keep on getting questions asked of you because you keep looking at the other way. How is the generator that Colby and I built, and I have to give Ian credit because Ian helped too. How is that generator like our windmill? That again Colby built because Colby's my little engineer. I say little, he's taller than me.
One is that they both have kinetic energy,
They do both have motion energy, yes.
and they both have the kinetic energy to turn on a light.
They both are used to turn on an LED light too, right? Did the windmill have a generator in it?
No.
Yes,
Hold on.
maybe.
Okay, so we didn't show it in block 2's picture. They both do gather and transfer energy. We didn't show it as well in block 1's picture, but in block 3's picture, I drew the windmill from the side so you can see it easier. There's a generator.
I told you.
This is the advantage of teaching this for 2 years. I need to draw a different perspective on my classes.
So that's why you
That
everything.
is a generator.
Oh.
The windmill has a generator. Put the chair down on all fours. And scoot the chair up so you don't have the temptation. So the windmill has a generator. Okay, that was something it had in common. Okay, so do you think inside that generator in the windmill, it had magnets?
Yes.
Because this, I use my flashlight. What do we ever do before phones with all these different purposes? Apps existed.
What?
See the magnets?
Yeah.
That is what is powering this generator. That's what actually creates the electricity in the generator.
A magnet.
Uh-huh. And they're being held apart by the hex nut. Now you can see the hex nut, can't you? There's one on top of the nail. I'll flip it over. There's one on the other side of the nail. So those hex nuts are keeping the nails, are keeping the magnets apart. And that nail is just giving me something to spin them. Spinning those magnets are what is creating the electricity. Okay. Those magnets are what creates the electricity. So inside the generator for our windmill, there's magnets. So this generator and the generator in that windmill both have magnets. Okay. What else makes a generator, this one, like the windmill?
I'll say the wire.
Both have wires. Those are coated wires with like a plastic. These are coated with enamel. So these are shiny, those are not.
And they both have a light.
And they both have an LED light. Yes. What else do they both have?
Both need wind.
This one doesn't need wind. I wish wind would turn that sucker. They both trans what? Transform. No, they transform.
Energy into light.
What kind of energy? Motion energy into light energy, well, into electrical energy first, right? Because that's what's going through the wire. And then that goes into light, right? So you have two transformations going on in both systems, right? They're both creating energy. Yes, ma'am.
I was trying to talk about magnets a couple days ago, and like how if you have a magnet, if you have two end magnets, one will be pushed off of the other.
Correct. And that was something I pointed out in the video yesterday, wasn't it? Uh-huh. Okay. So in your notebook, page 43. Page 43, key concepts checklist. So what energy concepts should we make sure we have on our model of the windmill? Because we have talked about so much in this module, haven't we?
They both have a generator.
What?
They both have a generator.
They both have a Genetica. What? Okay. So things that we've talked about, key concepts, energy, what? Energy transformations. That's a key concept, isn't it? That's a big one that we've most recently talked about. Energy transformations.
Can't see.
A sassy person, just like your teacher. Energy, what else? What else have we talked about? Energy transfers, absolutely. What would we do without Sky Una in here? I put her in the perfect seat because she's a lot like Jordan, right? Jordan used to sit in that same seat, and she used to give us a lot of our starting.
She used to get a lot of information.
A lot of information, but she'd be the one that would start our discussions. Sky Una does that too. Okay, so think about Allie versus Innocente running in the desk. And the last, not the last conceptual checkpoint, but the conceptual checkpoint before that, a relationship between energy and what was the difference between what Allie brought to the desk and what Innocente brought to the desk? He brought more what?
Energy.
Because he brought more. There you go. So relationship between energy and, there you go. Energy and speed. Let me zoom out just a little. Come on. There we go. Yes, they're not complete sentences. Okay. And then what was the other thing we've talked about? Light, sound, all those things are called what? Remember my sentence strips? Indicators of energy. Absolutely. Okay, guys. Indicators of energy. Oh, indicators.
Not indicators.
Yeah. I know I might be Southern, but I do spell correctly. Okay. Okay, so in your notebook, I think Skyuna is the only one. It might also be Hunter, who has not drawn on page 2 in your notebook. For them, this drawing is new. Page 2. I'm going to put up block 1's drawing. Block 1 has a different drawing than block 3. You need to amend your drawing because we've added a lot to this since we've been working on this, right? Page 2, you have a drawing, yes?
No.
Oh, page, where does it say up there? Page 5. Page 5, it's lesson 2. Page
That's
5.
not
Page 5.
Yeah, I got it now.
I certainly hope you didn't draw plants on that page.
Looks like you did.
Okay, so, well, then you have a whole new drawing to do.
Yeah, my drawing.
Because it's a great. All right, listen up. Class.
Yes, baby.
This is what needs to be there. If you're talking, you can't hear me. It needs to be the drawing, and you need to have these things, bless you. You need to have these things up there. Not this, but these things, because these are the labels that we have on the drawing. Forget about this for now, okay? Leave out all of this. But all of this, which is our labels, they need to be there. Okay, if you want to move closer, you can. Just see right here. It's a drawing. It's a grade. I need the talking. Stop. I'm going to take a picture and send it to you, Megan, okay? Sorry, guys, I'm right in your way. Quiet, please. Yeah. I've got to get my charger so I can put something in Canvas.
Thank you.
Thank you. Bless you. Let me see. See if I can print this picture. Here. Wow, that's bad. All right, who is still drawing and labeling? Okay. Holy, that was the opposite of fast. Yeah, keep that long footprint. Over a minute. Okay, there is the drawing. And I tried to put in the little generator right there. That's that little black circle is behind the green circle. Okay. Got it? That looks like a friendly little teddy bear. You know where the teddy bear image came from? Theodore Roosevelt, his nickname was Teddy.
Yeah.
And he went hunting. Yeah. So it was mocking him. That's where the name Teddy Bear came from.
Okay, I never even had to
Okay, so did everybody label their windmill? Wind, blade spinning, electric current transfers energy with that word transfers. Wind collides with the blades. We talked about collisions. Most of you saw a collision with a couple people in a desk because they just decided to get up and run at a desk. When the wind blows harder, more energy is transferred to the blades. What you were supposed to be able to see is when I more rapidly move the nail, the light bulb would glow longer and brighter. But the reality was just getting the glow at all seemed to be a miracle and cause nerve damage to our arms. Okay. Now I get to make revisions to that. Yay me. The words. You guys don't-
do we have to write that?
No, you don't make the revisions. All you have to have is what is written up to here. Okay, so the generator, what I have looks like a box. Where you go? Purple, this right here. I'm gonna write this in pink because I don't have anything in pink yet. I just need something different colored because there's already so much on this poster. You might have noticed. Generator behind the blades. Transforms what kind of energy into what?
Some kind of energy into
Transforms.
transform,
Well, what do we call this right here?
transfer,
What do we call this? We do call it kinetic, but they want us right now calling this motion energy into what kind goes into the wires?
electric,
Into electric energy. Okay. Windmill system, wind flies the blades, it transfers energy. And I'll add this in pink. Once again, they want us to just automatically make it space. Yeah, I don't have room for a whole sentence here. The motion of the spinning blades. Moves the magnets, just like it did in my generator. Inside the generator. Where the motion energy, it doesn't combine anything. Where the motion energy does what? Not transfers.
transformation,
Motion energy of the spinning magnets transforms.
energy. Into energy,
Transforms into
electric energy.
energy, electrical energy.
Boom, I got it right.
Yeah. Managed to barely fit it in.
Oh, that's
Okay. So turn to page 1 in your logbook. You're going to write this question there. Do you guys have anything written on page 1 yet?
No.
Okay.
I can't believe it. That was right, all that pink. That was no. Let's write all that pink.
Right now, I'm writing this here so that my online friends have more time with that picture. You're gonna write this question on page 1 in your notebook.
How
Do windmills change when into light?
So then we gotta answer it.
Yes. Take a moment in quiet. That means you need to be quiet. Think about it
What question?
and then answer it.
That's the last question of the day.
What is it?
That's the last question of the day.
No, we're gonna go over the conceptual checkpoint too. We're gonna try to go over that. How do windmills change wind into light? You have to admit today's lesson is short, isn't it?
Yeah.
Yesterday's was too, wasn't it?
Yesterday's was fun. Yeah.
Because the latitude and longitude.
Yeah.
All right, quiet, my friends. All right, page 1. How do windmills change wind into light? Yeah, you do. You have that drawing with lots of explanations into, and if you want to add all that stuff in pink because it helps explain more, go ahead.
It doesn't.
Okay, so answer that on the page. Okay, so answer this question on this page. This is page 1 in your notebook. Let me put this drawing right here. Zoom out.
So we answer the question on the same page.
Again, this is for my friends that are seeing this virtual. And now my contrast is being wonky. Y'all only have to do it one time. 3 times.
Yeah, but you only have to print it one time.
Yes. All right, stop talking, my friends, and answer this question. Haley, stop at the feet, please. All right, quiet, please. Okay, let me preview the conceptual checkpoint and see what we can go over from that. Okay, guys? Oh. Wow.
Wow, what?
Your conceptual checkpoint goes with that question. I would suggest you give as detailed an answer right now to that question as possible. And you might want to include that stuff in pink up there. Okay? Everybody hear me on that? And remember, on your conceptual checkpoints, you're allowed to use anything in your notebook, your logbook. So everything we've done today will most definitely help you tomorrow, okay?
So we do the conceptual checkpoint tomorrow.
Well, let me read the conceptual checkpoint question. We're supposed to go over the essential question, how do windmills change wind into light? And here's the prompt. A woman in a neighboring village heard about what William did to transform wind energy into electrical energy. The Boy Who Harnessed the Wind. We're going to read a little bit more out of it tomorrow. Okay, let me keep going with the prompt. Quiet, please. She is excited at the idea of using electricity to pump water. Develop an explanation for how this water can use a windmill to turn on a water pump and provide enough water for her family. In other words, it's going to be, how can you change windmills not into light, but into electrical energy and use that electrical energy to pump water? Yeah, like the Hoover Dam. But instead of using water energy to make electrical energy, it's going to be wind energy to make electrical energy pump water, which is exactly what William did. Okay.
I'm hungry.
Not the whole thing.
I'm hungry.
So this, you're going to have to tell me the generator. You got to tell me about the generator. Making electricity that transfers through wires, which is going to transfer to the pump, and the pump would pump water. And I know this because in the windmill model, the light is brighter when there's more wind. Okay, so it falls right in line with what you just wrote on your page. 1. Okay.
It's coming. It's coming. Big one.
Our lesson tomorrow, they want us to spend 30 minutes going over the driving question board, so we'll go back over it a little bit and talk about the questions that we've gone through, and then to go over the book, The Boy Who Harnessed the
Me
Wind.
too.
Then conceptual checkpoint. It's another short lesson. Then we're going to go over all the questions to the module assessment. And we're going to take the module assessment on Thursday, and we'll be out of module 2. Friday, we start module 3. Okay. Animal senses, which is my thing because I have a biology degree. Stop, please talking. Stop, please talking. Stop talking, please. Please stop coming. If you want to see, I showed my husband this. He said, that is ridiculous. I said, that's why I cut off the last few lessons. They wanted that generator to be turned sideways and used to build a windmill out of popsicle sticks, the paper plate thing that you guys built, and this. And you saw how hard it was for me to get it to make electricity. Can you imagine how many times it would tear down your windmill while you're trying to get it to make electricity, especially out of popsicle sticks? The other solution was for multiple children to bring a generator up in my classroom. I don't know if you know anything about those, but number one, very expensive. Number two, they have off gases. We would end up dying of carbon monoxide poisoning in here. So that's a big no, and heck no. So I skip all those lessons. I'd rather, survive, and my students all survive happily, healthy. Yeah, that. Okay, so we've gone over conceptual checkpoint. We've done all of today's lesson. The only thing I have left now is to grade your notebooks. Okay, so if you still have any of the RTI assignments for me, you may work on that. Put your first and last name on the back of it, put it in the basket so I can grade it. Because they didn't give me an answer key. I had to make my own answer key last night because Jackson already turned his in. So I had to make my own answer key when I graded his. Goes in the pink basket. Do you have a math RTI packet to do?
No.
Do you have an English RTI packet to do?
No.
Okay.
No.
They're probably going to give them to you today. They both had observations yesterday, so they were concentrating on that. Okay. So they'll probably do those for you today. That means you can work on Zern, you can work on extra math, or you can read a physical book in here. That means a book, not tumble books.
I saw this video about some extraordinary things that I thought you would like.
I need to talk and stop.
This guy named Jack who sailed the Titanic was found in 2020. That took a long time to rescue it.
Probably not real. Okay, so 35 north, 85 west. 35. 85 between 80 and 90. Maybe that's kind of it. Okay. Don't play the one over here on classroom printer. I gave you in my video. I gave you an answer for each one of those in my video. Okay. All right, Megan, do you have any questions?
So are we doing the
Megan.
conceptual checkpoint right now? Okay.
All right, so I'm gonna call the meeting done for the day, and I will see you tomorrow, Megan, okay?
Okay, bye.
Bye.